This mini lecture shows you how to draw chair conformations. Alright, let me show you how to draw a chair conformation. The first thing you want to do is draw what I like to call a lightning bolt. We're going to just do methylcyclohexane here, and I'll show you how to add other methyl groups later. Alright, so what I did was just draw like a jagged shape here and then join the ends of that jagged shape with two similar kinds of lines. Try and keep these parallel. I haven't done a particularly good job of that, but you should try and do that. It'll make it look nicer. And then we can put in our axial bonds. Now when we do that, I always start at the puckered end, or this end that's puckered upwards, and I'll put an axial group there. I would never draw an axial group pointing downwards here, because that would just disobey everything we know about bond angles. So we've got this one sticking up. The next one will be axial and sticking down, axial and sticking up. Let's draw that a little bit more up. This one down, this one up, and this one down. So there's all our axial bonds. Now we'll put in our equatorials. The equatorials will always point out from the ring, but in the opposite direction to what the axial is pointing. So if this axial is pointing up, this equatorial will be pointing down. This equatorial is up, this one's down, this one's up, this one's down, and this one is up. So there's all our equatorial groups in there now. Now I'm going to put a methyl group on here, and I'll put a methyl on this position. And now I'll put some hydrogens on. Remember, I'm just drawing methylcyclohexane here, just one methyl group. Didn't really matter where I put the methyl group. I wanted to put it here because that was going to help me out later when I was going to explain something else. Right, let's look at how this interconverts. I'm going to draw another chair conformation here. Again, zigzag, zigzag. There we go. Now I'll put in my axial bonds, and I always start again at the puckered end, this one, and I'll draw this one pointing up, and this one will be down, this one will be up, down, up, and down. Now I'll put in my equatorials. This one will be a little bit down, a little bit up, a little bit down, a little bit up, a little bit down. Let me draw that a little bit more out. There we go. And this one sticking up. Now it doesn't really matter with the equatorials if you point them to the left or to the right, but they do have to be pointing in the right direction relative to your axial bond. So if that axial is pointing down, this equatorial has to be pointing up, but it doesn't matter if it's left or right. Okay, now I'm going to put my methyl group on. Now since this methyl group was axial here, as we saw in the chair-chair interconversion video, is that if this is sticking up, it's still going to be sticking up after the conversion has occurred. But since it is now, if I star this carbon is this one here, this one is sticking up. It is now sticking up here, but it will now be equatorial. Now all that happened here with the interconversion was that this carbon moved down while this carbon moved up. So you can see it there. That's this carbon. I'll put a little dot on it. There it is there. I'll put some hydrogens on here. Now one other question that interests us about this is which one of these would be a favored conformation, or which one would be the lower energy conformation. Well, it turns out that in rings like this, large groups like a methyl group will prefer to be equatorial. Now the reason for that is because if I decide now to go ahead and draw my hydrogens on this methyl group, these hydrogens here really aren't going to interfere with anything. They're going to be out and away from the ring, so this will be low energy. This one, on the other hand, let's draw the methyl groups in, sorry, the hydrogens in now. And what can happen is that the hydrogen here can now interact with these hydrogens here. These are called flagpole hydrogens. And because of this interaction, this is going to be a high energy conformation. So what's going to happen is that cyclohexane will prefer to be in this conformation over here, with the methyl group being equatorial.